yeah, I just made another little video because battery is running out and I want to make sure I've got something for you. I don't have to repeat everything. So the difficult thing with integration, actually, there's a lot of methods and a lot of ways to remember this. It is tricky. Sine cubics. Now, you might look here, and obviously first place to look is to see on the right side, and there is nothing with cube. And then you look at the trig identities, again, there's nothing with cube. So now you need to start thinking a little bit out of the box. Can you think out of the box at this time? I can't really.
Sine 3x times sine. So sine x squared times sine x. And you can
Well
find
done.
the derivative of
Well
sine
done.
x and then sine x.
Well, you started really well. So we're going to split it to sine x times sine square x. Okay? Now at this point, again, I can't think, one is not the derivative of the other. So if you remember when we had things like cosine x, if this was cosine x times sine square x, then yes, I can start work with that. But when they're all sine, I can't. But for the rescue, to the rescue, come this trig identity, which you have learned. Okay? So now we can say, okay, we'll keep the sine as it is, but the sine square could be 1 minus cosine square x. And then again, I've split it. If you don't mind, I'm going to split it. No, let's do it slowly because you guys don't need that. So that's going to be sine x minus cos. So sine x minus sine x cosine square x dx. All of that is dx. And the integral of the difference is the difference of the integral. So sine x dx minus sine x cosine square x dx. And now, I don't know if it's easy, but it's manageable, okay? So, shall we do one? Well, let's do this one, and then when we do cosine cube x, we're going to stop here. So let's just do one. So that's easy, okay? What is the integral of sine x? Almost. Minus, okay? Minus cosine x, because the integral of minus sine is cosine. I'm adding the c on e at the end. Right, this was last lesson, okay? So we say, okay, it's a function and a derivative. So I'll put first of all minus. The function will be, what will be the function? So it's always, if this is cosine square, the function will be cosine cube x. It's always one power above, okay? And then to figure, the derivative of cosine is minus sine. So then actually I need to put a minus. In fact, that becomes a plus. Okay, and I don't have any constants, which is nice. I don't have 2 divided by 2. So let's look at this. When I'm not sure, okay, I always do that. So I'll write my suggestion, and then I do the derivative of that, and if I see if I need to get this whole thing without the integral, right? Okay. So the derivative of, hang on, I do have constants. I do, okay? So if I do the derivative of cosine cube x, the 3 jumps out. So I need to wait for him, divide by 3. So that will kill him. And then cosine square x, and the derivative of cosine x is minus sine x. So the minus jumps out, which we wanted. That's it. Okay, let's check this. I've got minus cosine. Hey, they had minus. Okay, again, something is wrong. Let's just pause that and see if we made a mistake. So in the book, they actually have a minus here, but me and Olivia thought about that. We just verified if you do the derivative of that, you do get a minus. In other words, that should be plus. But have a look. It's in page 84 in the examples there, and then check. And if you think we got it wrong, please let me know. Very possible. Okay. I'll pause and we'll move on. So our next mission is to do the similar thing to cosine cube x. And the strategy here is going to be the same because I don't have any trig with cube, I don't have any cube yet. So we're going to split it to cosine x times cosine square x dx. And the cosine we leave as it is, and the cosine square, we're going to use the same identity and we turn into 1 minus sine square x dx. Okay, now if you don't mind, I'll do, I'll skip a step. So I'm going to open these brackets and at the same time separates the integral because I've got an integral of a difference that's equal to the difference of the integrals. So it's going to be cosine x dx minus integral of cosine x sine square x dx. And if you don't mind, I'm going to stop here because this, we've done very similar thing just now, and we worked a lot on that last week. Okay, that's a simple integral of, what is it? Sine x, that would be simply sine x, and this is going to be integral of sine cube x, something like that, plus or minus sine cube x over 3. But we've done that, you know how to carry on from there. So I'm going to pause and we're going to go to the last example. Right, our last example is listed. So I've got a sine and a cosine. We've done last week, we've done a sine and a cosine. But what's the difference when we had sine times cosine last week?
Different powers.
They had different powers. We also did something like this. We did sine x cosine x. We did do that. But what's the difference?
This one has a 3.
Well, there's the 3. The angles. I mean, these are angles, right? In sine and cosine, we put angles. The angles are different. So you can't decide, that cannot be the derivative of that or the other way around. So that won't work. And for here, you need to use another set of identities, which you also learn this year, and that's that stuff. That helps you take multiple product of sine, cosine, 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 and sine, sine into a sum. Now, I've got a product here. Why is it good to take a product to a sum?
Then you can split them.
Exactly, all right? So, we said that, let's write it down here, because that's really important, okay? The integral of f of x plus g of x, plus minus, yeah, it could be anything. Okay, the integral of the sum is equal to the sum of the integral. Okay, as using your own words, you can split them. But there is no similar thing when we multiply. F times g, okay, dx, is not equal to the integral of f times the integral of g. Okay, that is very, very important. Okay, that is very important. This is true. There's equality here. There's an inequality there. That's not equal. Okay, I'll just to kind of emphasize it. That doesn't work. Okay, all right. So I want to move it into a sum. Okay, and I'm going to use this trig identity. So I've got, you've got 3 kinds. You've got for sine times cosine, cosine times cosine, sine times sine. So I've got sine times cosine, so I'm going to use that. Now I've got a 2 here. I don't have a 2 there, so that's fine. I'll divide the other side by 2. So what I can say is the 3x is like your A, and your 1x is like your B. So this thing tells me that this thing is half. I'll divide the whole thing by 2. Okay? Sine 3x times cosine x is sine a plus b, which is 4x. Okay? 3x plus x is 4x. Is this on? Yeah. 4x plus sine a minus b. A minus b. 3x minus x is 2x. Okay? Alright? And all of that dx. Okay? So I've got an integral of the sum. I can use that as a sum of the integral. So it's going to be half. Let's get that. That constant I can always get out. Okay? So let's get it out. Half times the integral of sine 4x dx plus sine 2x dx. Close brackets. Leaving the half there. What is the integral of sine 4x? By this now, this should be really easy. So again, we've got to think about what kind of function, what kind of trig function it will be. What's the integral of sine? Cos. Okay. So it should be cos 4x. We already divided by 4. And we just need to figure out is there a minus or not. That's probably the hardest thing. So the integral... So the integral of minus sine is cos. So the integral of sine will be minus cos, right?
Oh yeah, I'm gonna get the wrong side.
Yeah. When we move this way, it's differentiation.
Yeah.
When we're moving that way, integration.
Okay.
Okay? So from sine, we're going to get minus cosine. Okay? 4x over 4. Great. Plus. Okay? What will be the integral of sine 2x? Well, it's the same thing. We're going to get the same thing, isn't it? It's still going to be minus, but this time cos 2x divided by 2. Okay? What are these 4 and 2's? They're obviously waiting there because the 4 jumps out. Kill it. Okay? Plus c. Okay, let's see if we get the same thing. So it's basically cosine 4x over 8 minus cosine 2x over 4 plus c. I don't need to divide c by 2, right? Because it's just a constant. Let's see, minus 8 cosine 4x minus 4. All good, all good.